Hi, I'm Guang, 15 years old. In this lesson on the techniques and applications of definite integration, we are taking a look at two different examples and how we can solve them. So, take a look at the first example, a double integration e to the power of x over y dx dy across the region of y is greater or equals to 1, smaller or equals to 2, x is greater or equals to y, smaller or equals to y square. Right, so this is the kind of boundary and that is the kind of integrand. So first of all, we will look at what exactly would this boundary look like. So y is from 1 to 2. So that is something you would have to be aware of. Alright, an x-axis and a y-axis. Now, y is equal to x, that is just a straight line. X is equal to y square. Now, you probably know y is equal to x square, but x is equal to y square, that would just be something like this. Alright, so at first glance you might be wondering whether it is kind of like this region over here. But well, actually, since y is from 1 to 2, it will actually start from the intersection point. Alright, so well, I can just move this a little more downwards. Right, so y, we start from 1 and we will be ending at, well, if you really want 2, then that will kind of be a lot further away. So let's say we'll just have 2. So then you will see that this is the region. Alright. So this is y is equal to x and this is x is equal to y square. Right. So that is the kind of area that we will have. I will just be making this look a little better. Whoops. Alright, so this will be the kind of region you will be seeing. Right, so now that we know this, do we want to integrate with respect to y first, or do we want to integrate with respect to x first? So we take a look at this integrand, e to the power of x over y. Which one do you think you should use? Now, if you want to use y first, how do you integrate e to the power of something over y? So just by doing that, it is not quite possible. So how about let's take a look at what if we integrate with respect to x first. So integrating with respect to x first. Now what is the range for x? X, you have to go in this direction, which will go from your straight line to your curve, which is from y to y square. Alright? So from y to y square, and the range of y will just be from 1 to 2. So now integrate from 1 to 2. Now integrating e to the power of x over y, that means you will be having y e to the power of x over y, and then you have to substitute in x is equal to y and y square, and then dy. Right? So now you just have to substitute in your two values, which will see y e to the power of y minus y e. Right, so these will be the two functions you'll be seeing. Right, so the second term will be rather more easier to integrate, while for the first term, it will be a little more complicated. Since when you have y e to the power of y, you would have to put e to the power of y into the dy to get y d e to the power of y, and then afterwards use integral by parts. While for a second term, you have minus, so e will just become a constant, which means you'll have half y square. Then substituting the values of 2 and 1. Right, now we take a look at our first term again. Y e to the power of y, substituting the values of 1 and 2. Then you'll have to subtract, integrate from 1 to 2, e to the power of y dy. And then once again subtract e over 2. So you just have 4 minus 1, which is 3. So 3e over 2. Alright, so what's so special about our first term? You'll have 2e squared minus e. Well, for this term over here, it'll be minus, so e to the power of y, substituting the values of 1 and 2, which is minus e squared plus e. And then minus 3e over 2. So your final answer will be e squared minus 3e over 2. Alright, so this is the final answer you get for the first example. E squared minus 3e over 2. Right, so how exactly do we solve this question? Now of course, you start from your boundaries. Boundaries are one of your most important things. And with this boundary, then you can know, since you need to integrate with respect to x first, you will be able to know what direction is x integrating from and to, although you could really tell from your boundaries that you're just given, but a graph makes it easier to see. And then afterwards you just use integration while using integral parts, then a bit more integration to get your final answer of e squared minus 3e over 2. Right, so that is all for our first example. Next we'll be looking at the second example we'll have. Alright, our second example. Well, we have double integration 4xy minus y cubed dx dy, and d, well, the capital D, not the small d in dx and dy. So d is bounded by y is equal to square root x and y is equal to x cubed. So what will this boundary look like? So y is equal to square root x. That will look something like this. Similar to the one you have in the previous question, well, it's just changed a bit, since if you have x is equal to y squared, y can be negative, but if you have y is equal to square root x, then y has to be positive. Right, so this is y is equal to square root x. Now, the next one you have y is equal to x cubed, which you'll have something like this. Right, so this here is the boundary you're going to have. Right, so of course you have to determine where is that intersection. Now you just have to equate square root x and x cubed to get 1, 1. Right, so now we know where our integration boundaries are. Well, of course you also label this y is equal to x cubed. Right, now there are two different kinds of methods. Well, you can integrate with respect to x first, or you can integrate with respect to y first. So what if you want to integrate with respect to x first? So you're going to have this double integration 4xy minus y cubed dx dy. Integrate with respect to x first, which is you're going to have from the curve of x is equal to y squared to the curve of x is equal to cubic root y. So from y squared to cubic root y, and the ratio y will be from 0 to 1. Alright, so let's get to work. Now we see 2x squared y minus xy cubed, and then substituting the values of y squared and cubic root y, then dy. So in this part, of course, next you're just substituting the values for x, and the values for x you're going to have is, so when you substitute in cubic root y, you're going to have y to the power of 2 over 3. So 2 over 3 makes that 5 over 3, and then minus 2y to the power of 5, and then minus y to the power of 10 over 3, and then plus y to the power of 5. Right, so these will be the kind of integration you'll be seeing. Well, of course, you can also simplify these two to make just a minus y to the power of 5. And next, since you need to integrate them, so 2 multiplied by 3 over 8, y to the power of 8 over 3, substitute in 0 and 1. And then since these two will just become minus y to the power of 5, you're going to have minus 1 over 6, y to the power of 6, substitute in 0 and 1. And then minus 3 over 13, y to the power of 13 over 3. Then substitute in the values of 0 and 1. Well, at this point you can choose to just work it out, this entire calculation, or you can just punch your values into a calculator and see what it will give you. Or at last, it will give you the value of 55 over 156, which is right. So that is the answer for this question. Now, what kind of methods do we use? Of course, again, we looked at the boundary of the integration you're going to see, determining your start range for x, start range for y, and of course their respective end values. And then with that information, you will determine the boundaries, and of course your boundaries depends on whether you want to integrate with respect to x first or integrate with respect to y first. Then you do some simple integration, just have to be aware of your different powers, different simplifications, and at last you can just get this kind of value, which when you substitute in the y values, you get the final answer of 55 over 156. Right, so I hope for this question, you're clear with them so far. So that will be for these two types of examples. So once you master the kind of methods, it should be rather simple, since it is pretty much similar every time, alright? So I hope you enjoyed this here, and thank you for your watching.